All right, so here we are with these exercises. Hopefully you tried these first and you are watching this because you are either trying to check your answers or you got stuck. Remember, if you're stuck, then try to just watch until you get unstuck and then try to do as much as you pause it again to try to do as much as you can yourself. If you're just checking your answers, feel free to skip ahead to where you can see the answers in the video. Okay, so with this one, the 12x is supposed to be the 2rx part. So we're saying 2 times r equals 12. So what is r? Well, just divide both sides by 2, and you can see r is 6. So then we need to have a plus r squared here. So that's going to be r squared is 6 squared is 36. So I'm going to rewrite this as x squared plus 2 times 6 times x. That's the r is equal to 6 there. That 12 is 2x. And then I'm going to write a plus 36 here, but then you can cancel it out with a minus 36, and there's still the plus 20 sitting there. So again, all of this stuff, 36 minus 36 plus 20, all adds up to 20. And so that makes this part a perfect square trinomial. We have x squared plus 2 times 6 times x plus 6 squared. So that stuff you can factor into x plus 6 squared. That's the x plus r squared. And then there's a minus 36 plus 20 here. That stuff turns into negative 16. Okay, so that is in vertex form. If you wanted to be really precise about it, you could write this as 1 times x minus negative 6, because x minus negative 6 is the same thing as x plus 6, and then you have a minus 16 here. So that's what we need to do to get it precisely in vertex form, which is what this is looking for, so that you can see that a is 1, the h is negative 6, and the k is negative 16. So I guess you could also write this, instead of minus 16, you could write it as plus negative 16 to be super precise. But all right, so that's that one. Give yourself a pat on the back if you did that one on your own, or if you just got a little help and then worked through it mostly yourself. These are very tricky. All right, so here's a slightly trickier one. We want to get x squared minus 3x plus 2. So the reason this is a little tricky is that the 2r is negative 3, which means when you divide this by 2, you get a fraction. And you saw with the last example, whatever number that was, part E here, when you have fractions involved, things get a little messy. Or actually, let me go back a second. I should be calling this, we already have the negative there. I'm going to make r be just 3 over 2. And we'll see what I mean here. I want to do it like I did with here, where you just leave it with r as a positive number, but then have it subtracted, like I did with a and b in the last example 4. Okay, so anyways, this is going to be x squared minus, there's that minus, 2 times r, that would be 2 times 3 over 2. And then we need to have a plus r squared. Well, let's see. If r is 3 over 2, then r squared is going to be 3 over 2 times 3 over 2, which is 9/4. So we need to have a plus 9/4 there. Oh wait, I forgot the x. Excuse me, let me fix that. Okay, so 2 times 3 over 2x is the same as that minus 3x here. And then, okay, so again, we have the plus 9/4, and we also need a minus 9/4 to cancel that out. and there's still the plus 2 hanging out. So the 9/4 minus 9/4 plus 2 all adds up to 2. Okay, so now this stuff that I'm bracketing in red is the perfect square trinomial. So I'm going to write that as x minus 3/2 squared. So that part factors out like so. Then on the outside, there's this minus 9/4 plus 2. Well, we need to combine that. So let's see. We need to have them both be over 4. So I'm going to try to write that 2 as something over 4. So let's see. What divided by 4 equals 2? That would be 8/4 is 2. So if we have minus 9/4 plus 8/4, that combines to make negative 1/4. So I'm going to write it that way. Forget the squared there. And then to get this precisely in standard form, I'm going to have the f of x equals 1 there. Keep forgetting to put boxes around my answers. Always a good habit. And then instead of writing negative minus 1/4, you can write plus negative 1/4. And that's the same thing. So the a is 1, the h is 3/2, positive 3/2, and the k is negative 1/4. All right, tricky stuff. Oh, my box just crossed out that 2. There we go. Okay, if you got that, give yourself a big pat on the back. You are now able to do some of the hardest questions in the class. All right, so let's go on to exercise 2 here. So we have a bookstore finds that if they charge P dollars for a t-shirt, then its revenue from t-shirt sales is given by this function. And then for part A, we want to know what prices result in 0 revenue. So 0 revenue here means that we're going to make the result be 0, or the whole f of p be 0. But we want to know what is p. So we're going to leave p as the variable to figure out what that price is. That makes it so you get r, or f of p, equals to 0. So it's going to be 0 equals p times 1,000 minus 20p. And, oh hey, this looks good. If you have done the D.1, D.2 homework, and also the, let's see, 3.2 homework, which is always good to stay on top of the homework to prepare for the next classes. If you've done those, then this is an easy one for you to solve, because you have something times something else equals 0. So that this one would give you p equals 0. If 1,000 minus 20p, that whole thing is equal to 0. That would also work. You'll have 1,000 minus 20p equals 0. If this whole thing is 0, well then whatever p is times that will still be 0. So let's see, I'm going to subtract the 1,000 from both sides. You'll get negative 20p is negative 1,000. Divide both sides by negative 20. And you'll get p is equal to, let's see, that'll be 50. Okay, so the deal here is if they charge $0 per t-shirt, if they're giving away their t-shirts for free, then they're going to make 0 revenue. And if they charge $50 for a t-shirt, they're going to make 0 revenue because nobody's going to buy a $50 t-shirt. Unless, I don't know, maybe it's like the new Yeezy t-shirts or something. Maybe people would buy it. But most t-shirts, people aren't going to do that. So what prices? They're $0 and $50. So that's the answer to that. Now, what price should it charge in order to maximize the revenue? Well, let's think to analyze this question. Let's think about what's going on here. If we were going to graph this function, let's say you have R is the vertical axis and P is over here. Well, the points that we just found are 0 and 50. Those are values of P that make it so the revenue is 0. Now, to maximize the revenue, we're going to get the vertex of this parabola, because after you distribute the P in there, you'd have a negative 20P squared. And negative 20P squared is going to make you have a downward opening parabola. So the question is, what is this point here? We want to know what is the price that gives you the maximum revenue. So that maximum revenue happens at the vertex. So what is the price there? Well, let's get this into vertex form to figure out where the vertex is, to figure out where the maximum revenue is. And this is a common thing, a common kind of application problem with quadratic functions is you want to maximize the output of the function, like maximize the y-coordinate, or maybe minimize the y-coordinate. That's always going to happen at the vertex. It would be the maximum if it's opening downwards like this, or if it was opening upwards, if it was opening upwards, then the minimum would happen at the vertex. Okay, so let's figure that out. So we want to get this into vertex form. So we're going to complete the square to get it into vertex form to see what the vertex is. So I'm going to start by distributing that P in there. Like so. P times 1,000 and negative 20P squared is what you get. And I want to try to write this, I want to complete the square. So to complete the square, you don't want to have the negative 20P squared. So we're going to factor that out. I'm going to write this with the negative 20 on the outside, with P squared there, and then we want to do negative 20 times something to get this 1,000 here. Well, negative 20 times 50 is 1,000. But we want to do negative 20 times negative 50. And this should still be times P. So let's just check that that works. Negative 20 times P squared is negative 20P squared. Negative 20 times negative 50P is 1,000P. Okay, so now that's been factored that way, we can start by completing the square on the stuff inside the parentheses. So here, the negative 50 must be the, oh sorry, I'm just going to leave it as positive 50. 50 must be equal to the 2r. So if you divide both sides by 2, you'll get 25 equals r. And we need to have a plus r squared in there. So r squared is going to be 25 squared, which is 625. Okay, so I'm going to take this negative 20 times P squared minus 2 times 25P, like so, and then plus 625 minus 625. A little short on real estate here. Okay, so that plus 625 minus 625 is the same as that 0 that's in there. And then this part under this red bracket is what you can use to complete the square. So that's going to look like negative 20 here, and then just that stuff in there is going to become, this was a minus here, we're going to get P minus 25 squared. And then there's still that minus 625 on the outside there. Now the trick is we can distribute this negative 20 in here again, and we're going to get negative 20 times p minus 25 squared, and then negative 20 times negative 625 is going to be positive 12,500, I think. Let's check that one with a calculator. Yep, okay. So that is in vertex form. So now we can see that the vertex is, this is p minus 25, so that's like the h there is 25. And the y coordinate of the vertex is 12,500. So let's see, so that's actually the maximum revenue they can make from selling these t-shirts is $12,500. The price at which that happens is the 25. So this answers the question. This is now $25, and this is $12,500 there. And it's good to make sure that makes sense, because, and you might have gotten this anyways, if you like just drew a picture here at the beginning, before I actually did this completing the square, if you know that parabolas like this are symmetrical this way, and it's crossing the x-axis at 0 and 50, then the vertex is going to be halfway between those. So you might just be able to see, using what you know about the graphs of parabolas, that that's going to be at 25, and save yourself some work that way. But practice completing the square is also valuable practice. All right, so let's look at exercise 3. So we're given the perimeter of a rectangle is 64 centimeters, and if the width of the rectangle is x centimeters, let's give a formula for y, the height of the rectangle in centimeters, in terms of x. So I'm going to try to draw a little picture of this rectangle here. So let's say this is x and this is y. Then this also must be x over here, and this is y on this side. So, and we know that that all adds up to 64. So I'm going to give you a big hint here. If you're trying this on your own and you're stuck, then after I give you this hint, maybe pause it and keep trying. So if we have x plus y plus y adds up to 64 centimeters, I'm going to write that as 2x plus 2y equals 64. So that's my big hint, and you might want to pause it here. So, all right, so now that you're back, we're going to try to get a formula for y. So that means we want it to be y equals, so I'm going to subtract the 2x from both sides. That'll leave you with 2y is 64 minus 2x. And from there you can divide both sides by 2. And that will leave you with y equals 64 divided by 2 is 32. 2x over 2 is minus x. So that is a formula for y in terms of x. Okay, so now using this formula, let's give a formula for the area in centimeters squared in terms of the width x. So first of all, area is length times width, or width times height, or whatever you call the two lengths. In this case, that's x times y. Now, if we wanted to just be in terms of the width x, then this is now in terms of x and y. So we want it to look more like a equals x, and then we're going to substitute the y with 32 minus x. This thing is equal to y, so I'm going to write that here. So now that is in terms of the width x. Okay, So that's a formula for a in terms of x. And if we want to find the lengths of the sides of the rectangle that give you the maximum area means that we're going to look at the vertex of this parabola. So this is going to be some kind of parabola that's going to be opening, let's see, is it opening upwards or downwards? If we have x times negative x, that'll be negative x squared. So it must be some kind of opening downwards parabola. So the maximum area is going to happen at the vertex. So let's do the same thing as before. Let's try to find that vertex. So to find this vertex, we're going to convert this into vertex form. So I'm going to take this and write it as a equals 32x minus x squared, so we can try to complete the square on this. Let's see, I don't want to have a minus x squared. I want to have, I'll write that as negative 1 factored out with x squared there, and then negative 1 times negative 32x will make that plus 32x if you were to distribute this back in. So factoring that out, so you just have 1x squared there. Okay, so then let's see. We have minus 2rx here. It must be the minus 32x. So we can say 2 times r is 32. So r must be 16. This should be 2. So r is 32 divided by 2 is 16. R squared is going to be 16 squared, which is 256. So that's what we're going to have to do, is use that to write this as negative 1 times x squared minus 2 times 16 x, that's the minus 32x, and then plus 16 squared. Ran out of room again. So we have plus 256 minus 256, so that we're not actually changing it. And this part is a perfect square trinomial. So we're going to write this as negative 1 times, that'll be x minus 16 squared. That's the factored version of that perfect squared trinomial. And then there's still that minus 256 there. And we can distribute the negative 1 into these two terms. And that'll give you a equals negative 1 times x minus 16 squared, and then negative 1 times negative 256 is positive 256. Okay, so this is now in vertex form. We can see that it is opening downwards, so it makes sense that I drew it this way, because you have a negative 1 here for the a. And we can see the vertex, this is written in vertex form. We have the a is negative 1. The h is 16, because you have x minus 16. And then the k is 256. So the vertex is at x equals 16. So so that tells you that the maximum possible area here is 256 square centimeters. So if x is equal to 16, what is y? Let's see. We have this formula for y in terms of x, so I can write this as y equals 32 minus 16. That will give you y also equals 16. So, yeah, so it's actually going to be a square. There we go, a square, which is 16 centimeters by 16 centimeters. And the maximum area is 256 square centimeters. So it turns out if you have a longer, skinnier rectangle with like a larger X here, you could still have the same perimeter, but your area would be less. Same thing if you have a really small value of X, which gives you a tall, thin rectangle, the other way, that would give you lesser area that way. So a square is the kind of rectangle that maximizes the area inside of it if the perimeter is fixed. So keep that in mind if you ever want to, like, I don't know, you have a certain amount of fence and you want to like enclose a large area for your chicken coop inside of it, and you want the chickens to have the most room, but you only have so much fence, then try to make that fence a square for your chickens. All right, that's that section. If you did this problem, give yourself a big pat on the back. This is tricky stuff. And I'll talk to you in the next video.